Draw each angle in standard position. Identify which quadrant it is in, and identify a coterminal angle. In example A, we have the angle 135 degrees. If we want to draw it in standard position, we need to start the angle with its initial side along the positive x-axis and its vertex at the origin. Now, 135 degrees, we want to think about where that's going to be. Well, let's list the quadrants first to kind of remind ourselves. We have Roman numeral 1, first quadrant starting in the upper right-hand corner, moving over to quadrant 2 in the upper left-hand corner, down to quadrant 3, and then over to quadrant 4. And so where is 135 degrees going to be? Well, we just said that 360 degrees is all the way around. And so 90 degrees would be up here, 180 degrees, halfway up there, 270 degrees bottom, and then 360 degrees back where we started. 135 degrees is somewhere between 90 degrees and 180 degrees. So we are in quadrant 2. Now, where is it going to be between the 90 and the 180? Well, one thing you can do is just say, well, if I'm at 135 degrees and I take away 90 degrees, what's left over? 45 degrees. So I'm 45 degrees into quadrant 2. The quadrant 2 represents a rotation of 90 degrees, and so 45 degrees is just half of that. And so I would end up on the diagonal, say represented by the line y equals negative x, just halfway in between. This is a positive angle. It rotates from its initial side to its terminal side counterclockwise, and we can label the measure there just above our little angle symbol. Now it's asking for us to identify a coterminal angle. Now a coterminal angle is going to be having the same initial side and terminal side. Now notice we don't need to write in initial side and terminal side here because we can see that with the angle symbol, it's going away from the terminal side and pointing towards the terminal side. So that's how we know. Okay, so if we want a coterminal angle, we can still start at that initial side and then point towards the terminal side. We'll call this new angle, say, beta. And if I want to determine the measurement of beta, I can. Okay. So beta will be, let's see, it has to rotate through 2 quadrants, so that's 180 degrees. And since this is a negative rotation, I want to list that here. And then it has a little bit more in quadrant 2. It rotates the 45 degrees that the 135 degrees did not use up, so right in there. So this is just adding in negative 45 degrees, and so we end up with negative 225 degrees. All right, let's look at example B. We want to draw negative 120 degrees in standard position. Now with standard position, we're always starting on the positive x-axis for our initial side with our vertex at the origin, even if we have a negative angle. Now to go negative 120 degrees, that's going to be negative 90 degrees plus 30 degrees more in that same direction. So 30 degrees is about a third of 90 degrees, and so we're about a third of the way into quadrant 3. So there's our quadrant, and we can label this as negative 120 degrees. So what would a coterminal angle be? Well, we can use the coterminal over here and call it whatever we want. Maybe we want to call this one gamma. So we want to call it gamma. That's another Greek letter we'll see. So I'll just write it up here. That's how you spell it. So there's gamma. Well, how big is gamma? What's its measurement? Well, gamma goes through 2 full quadrants, so that's 180 degrees, plus a little bit more. Well, how much more? Well, let's see. Down here, from here to here, this angle measurement is just 30 degrees. So gamma is going to use up 60 degrees of this quadrant. So I'm going to have 180 degrees plus the 60 degrees. It's going to give me a measurement of 240 degrees. Now, one thing that I can notice is that if I take, say, my original angle measurement, 135 degrees, okay, and I take away 360 degrees, actually end up at negative 225 degrees. So they're just 360 degrees away from each other. Now let's try that over here. If I take my negative 120 degrees and I just add 360 degrees, I get to 240 degrees. So I can see that the coterminal angles are just 360 degrees away from each other. Now my next example are how many coterminal angles does 150 degrees have? All right, well, let's first start by drawing it in standard position. So I have my initial side on the positive x-axis with the vertex at the origin. Now 150 degrees, how do I want to think about that? Well, it's certainly bigger than 90 degrees, but less than 180, so I know I'm going to be in quadrant 2. And I notice that it's 30 degrees short of 180. And if I think about a quadrant and I divide it up into, divide it up into thirds, about like that, each one of those thirds is going to be 30 degrees. So I want my 150 out along there. So there's just 30 degrees left to get to the 180. I'm going to label this as 150 degrees. And I want to think about how many coterminal angles does it have? Well, we know that its initial side is along the positive x-axis. Its terminal side is over here in quadrant 2. And so for a coterminal angle, it just needs to have the same initial and terminal side. So maybe the obvious one is where I just kind of go backwards or go the other way. And maybe I call this one theta. Okay, I'll do a different color green here for the next angle. What if I went the same kind of way as theta, but instead of stopping at the terminal side, I go past it, and then I just keep going until I finally hit it on that next go around. Now that's going to be a pretty big negative angle, but it's certainly still a coterminal angle by the definition, and maybe I call this one beta. Okay, well, what if I did that same kind of idea, but instead of passing by the terminal side once, let's say I pass through it twice, finally come back around and hit it, and then maybe I call that one gamma. All right, so what have we gotten ourselves into? Well, we've already drawn these 3 different coterminal angles, and I think we're starting to see that nothing is there to stop us from continuing to create unique coterminal angles by just adding on another rotation. And we haven't even considered going the same direction as that 150 degrees to create these positive coterminal angles, which are also available. And so what we have here is that 150 degrees and any angle has an infinite, or we'll say it has infinite coterminal angles. Okay, so in general, what can we say? Well, we can say given an angle, let's do alpha just to get used to some more. Angle alpha, so this is its symbol, alpha. Alpha has coterminal angles. This is what they would look like. So alpha plus 360 degrees times k, where k is an integer. So that just means that all of the coterminal angles are just some amount of rotations away from that original angle alpha. They could be, if k is positive, then we see that that would be in the positive direction, and again, if k is negative, in the negative direction. But each way would create a unique coterminal angle for alpha.